So we're going to start with chapter 22, looking at evolution or descent with modification. So you're probably aware of the fact that Charles Darwin was the scientist who popularized this idea of evolution. And he did so with his book on the origin of species. So when Charles Darwin was looking around at the earth around him, he took concepts from what he saw. So he was looking at animals that looked like other animals that he'd seen in other places, but not quite the same. He took in what he was reading about geography, about fossils, and he came up with this concept called descent with modification. So if you actually go back to the original book on the origin of species, he only uses the word evolution once, and it's in the very last page, and he says evolved. Throughout the entire work, instead of evolution, he actually uses this phrase descent with modification. So evolution really just means these patterns of change, these observed patterns of change. What's really interesting is how this occurs. And so what he was positing is that this happens by a means of natural selection, which is this mechanism of change. So let's start by looking at some of the traditional views of the day before Charles Darwin came around. So we had Aristotle, who was a Greek philosopher in the BC era, and Aristotle believed that there was a fixed hierarchy to nature. So if you look at this scala naturae, which is the hierarchy, inanimate, so non-living things are at the bottom, plants, lower plants and higher plants, not sure what that actually means. And as we go up this hierarchy, we get kind of more and more advanced. We got fish, whales, birds up at the top, quadruped mammals almost all the way to the top, and then the very top we've got the best, of course, humans. And this scale held fairly closely with the Old Testament views that God designed humans and therefore we were perfect. And this held for a very long time. It wasn't until Carolus Linnaeus, and there's not a lot of names that I'm going to ask you to memorize in this class. Obviously, Charles Darwin is one. Here's another name you need to know, Carolus Linnaeus. And he developed a different type of classification system called the binomial nomenclature. So bi means two, nomial is name, so this literally means two names, and then nomenclature is just a term that means naming. So it's two naming. So for example, Homo sapiens, this is humans. And so with this naming situation, he came up with this branch of biology called taxonomy, where we classify things into nested groups. So it's still hierarchical, but now everything is nested. So we've got from very specific species, Panthera pardus, inside of genus Panthera, inside of family Felidae, which would have other large cats like lions and tigers, inside of order Carnivora, inside of class Mammalia, right? This is where humans would join in. Inside of phylum Chordata, inside of kingdom Animalia, inside of the domain. And so we came up with this hierarchy, and you should know this: domain, kingdom, phylum, class, order, family, genus, species, where the largest are down here. These are the most broad, and then these are the smallest or most specific. Over time, people had ideas originally that the earth was created and it had remained the same ever since its creation 1,000 years ago when God said everything be. The discovery of fossils and of rock layers had started to challenge that idea. And so this is one of the things that Darwin used to come up with the idea that maybe things were changing. They weren't just the same as when they miraculously appeared on Earth. So we have strata, which are just layers of rock, and the oldest strata are down here at the bottom, and as time occurs, new layers are put on top, and so the youngest layers would be up here at the top. And so you could look at the difference of the organisms, the fossils you find in these layers, and see change over time. Georges Cuvier was one of the first founders of the study of paleontology, which is studying fossils and things that are found in these strata. Some of the early ideas of how the Earth changed over time, there was this idea of catastrophism, which was that between each strata there was some sort of gigantic event. And we see some examples of that. So there was a big extinction here. There was a big extinction here. This would be the extinction of the dinosaurs here. And so that would definitely count as some kind of catastrophic event. James Hutton came along later with this idea of gradualism, where he said, no, it's not catastrophic. What's actually happening is that there's tiny gradual changes happening all of the time. And if you look at the fossil record, there's definitely some evidence of this, that fossils changed slightly over time. So he wasn't super wrong either. And then Charles Lyell came up with this idea of uniformitarianism. And uniformitarianism was this idea that the same geological processes that were happening in ancient Earth are probably the same geological processes that are happening now. So the mechanisms that caused change before are probably still causing change now. And he's not completely wrong either. So we do see evidence of kind of all of these different ideas of how the Earth has changed over time. All right, so this is a fun one. Here's another name you should know, Jean-Baptiste de Lamarck. And he was one of the first people to hypothesize that species, that animals, were changing over time. And in the era right before Darwin, this was crazy. This was new. This went against what the church was teaching. This went against what colleges were teaching. So this was revolutionary. He got it wrong on how it happens, but he was right that there was change. So he proposed something called the inheritance of acquired characteristics. And his idea was that the more you used something, it would change. And if you didn't use something, it would kind of go away. So picture this. We've got giraffes. And giraffes have teeny tiny necks, like what you might expect a short-necked giraffe to look like, right? Here's my neck. And unfortunately for giraffes, the food is up high, and they can't reach it with their short little necks. So the giraffes work really, really hard, and they stretch, and they use their neck muscles, and they work really hard to stretch and reach, and eventually their necks grow to be really large, and now they can reach the food that they were trying to eat. And if you think about this not as giraffes, but more be as like humans, right? If there's something on the top shelf, and you just reach and reach and reach and try really hard, and you use those arm muscles and you use those arm bones, is your arm going to grow really, really long so that you can reach the top? No. This idea of acquired characteristics was that some kind of characteristic that you acquired during life would then be passed on to your offspring, which is silly, right? If you think about it, somebody who comes back from a war with an amputee, right? They lost a leg or an arm, and then they have a baby. Does that baby come out without those limbs? No, that would be crazy. Not normally, anyway, right? So the offspring wouldn't have that acquired characteristic of the lost limb. Instead, they come out with their own forelimbs because that's what genetics had predisposed us to. And we know this now. It sounds very silly to think that giraffes got long necks by just stretching them and using longer, farther and farther leaves. But he was key in this kind of change of thinking that animals did change over time, that we aren't all put here the same way that the Bible said specifically, right? That 1,000 years ago the planet was exactly the same as it is, the animals are exactly the same as they were the first time they were put here. And so that was kind of a revolutionary change in ideas.